दोस्तों, आज हम यूनिट 8 जो कि डाटा ऑर्गेनाइजेशन एंड ग्राफिकल रिप्रेजेंटेशन को रीड आउट करने वाले हैं। मैं होप करता हूँ कि आपने पिछले सभी वीडियोस को देखे हैं, यानी कि यूनिट 7 तक जो कि कल तक अपलोड किए गए थे, सभी को आपने देख लिए हैं। और ये यूनिट 8 है। और आज जब मैंने ये अपलोड किया है, ये आज संडे है। आज संडे 20th। आज मैं कंप्लीटली ट्राई कर रहा हूँ कि सभी यूनिट्स BPCC 134 यानी कि साइकोलॉजिकल रिसर्च एंड स्टैटिस्टिकल मेथड्स एंड साइकोलॉजिकल रिसर्च BPCC 134 की जो टेक्स्ट बुक है वो पूरी की पूरी रीड आउट हो जाए संडे, क्योंकि जो इग्नू की एग्ज़ाम्स वो जल्दी ही आने वाली है। ठीक है, तो इससे पहले ही बच्चों को प्रिपेयर करने के लिए एटलीस्ट 2 दिन तो मिलने चाहिए ही। उसके बाद में मैं इवन ट्राई कर रहा हूँ कि साइकोलॉजिकल डिज़ॉर्डर्स जो कि और एक किताब है उसको भी अपलोड कर पाओ, साइकोलॉजिकल डिज़ॉर्डर्स। आपको बस ये करना है कि सभी वीडियोस मेरे कम्प्लीटली देखनी है। और दूसरी बात ये है कि लाइक और सब्सक्राइब तो करना ही है, क्योंकि उससे एक तो लाइक से मेरी तो मुझको क्या बोलूँ उसको, वीडियो बनाने के लिए ताकत मिलती है। ठीक है, और सब्सक्राइब करने से आपको मैं अगली जब वीडियो डालूँगा नोटिफिकेशन आएगी। ठीक है, इससे आप मिस आउट नहीं हो पाएंगे। तो चलिए शुरू करते हैं यूनिट 8 डेटा ऑर्गेनाइजेशन एंड ग्राफिकल रिप्रेजेंटेशन। इसका हम इंट्रोडक्शन देखेंगे।
8.1 Introduction. The objective of all statistical inquiry is to describe and understand the population of interest. For example, in an exit poll survey, a news channel wants to assess the political attitude of the voters, how they are going to vote in *. Dr. Vijay Vigas, Assistant Professor, Abe Faria Postgraduate Department of Psychology, St. Xavier's College, Goa. Statistical Methods I. 130. The upcoming election, and what are the chances of current government to come back in power again? This information about the population of interest can be gained from a number of statistical inquiries. Exit poll surveys provide tentative information about which party will gain what percentage of votes in which state of India and so on. Such exit poll surveys make use of basic statistical techniques that can be categorized under descriptive statistics. In the previous unit we mainly discussed about the term statistics, its definition, nature and also key terms. We also discussed about scales of measurement and the two main categories of statistics, namely descriptive and inferential statistics. In the present unit, we will mainly focus on the varied aspects of descriptive statistics, viz., classification, tabulation, organization and graphical representation of data. One of the most basic yet important method known as frequency distribution will also be discussed in this unit. Further, we will also discuss the method of cumulative frequency distribution, percentile rank and graphical representation of data. 8.2 Classification and tabulation of qualitative and quantitative data. Any data can be qualitative or quantitative in nature. Qualitative data are measures of types and are denoted by a name, symbol, or a number code. They are types of information that have features that cannot be measured. In simple words, qualitative data are data about categorical variables. Some examples of qualitative data are the smoothness of your skin, and the color of your eyes, the texture of your hair, the softness of your palm, etc. Whereas, quantitative data states information about quantities, that is, information that can be measured and written down with numbers. In other words, quantitative classification refers to the classification of data according to some characteristics that can be measured. Examples of quantitative data are weight, height, shoe size, and the length of fingernails, income, sales, profits, production, etc. In descriptive statistics, classification and tabulation of data, whether qualitative or quantitative, are two important functions that will help the researcher in organizing the data in a better manner so that further statistical analysis, whether by computing measures of central tendency, measures of variability or inferential statistics, can be carried out. In this context, we also need to explain the term univariate analysis. The term univariate implies that there is only one variable. And when statistical analysis is to be carried out with just one variable, descriptive statistics are used. For example, if a researcher wants to study achievement motivation of students in class 10th, the data obtained, with the help of a standardized psychological test, cannot be subjected to inferential statistics or higher-level statistical techniques. The researcher will be able to classify and tabulate the data based on the students who secured higher, lower, or moderate scores. She may further be able to compute mean, that will be discussed in the unit on measures of central tendency, and standard deviation, that will be discussed in the unit on measures of variability. Data organization and graphical representation. 131. Thus, in the context of univariate analysis, we mainly focus on the use of descriptive statistics. In the present section we will discuss classification and tabulation of data. 8.2.1 Classification. Data classification is a method of organizing data into groups for its most effective and efficient use. A well-planned data classification system makes vital data easy to find and retrieve whenever required. In other words, the process of ordering data into homogeneous groups or classes according to some common characteristics present in the data is called classification. For example, it is a common exercise that during the process of sorting letters in a post office, the letters are classified according to the cities and further arranged according to streets and other details, so that it becomes easier to deliver the letters to its destination. In the context of research, the data collected by a researcher is arranged in formats that will help him/her draw conclusions. Basically, classification involves sorting the data based on similarities. Once the data is classified, the researcher can proceed with further statistical analysis and decision-making. Some of the main objectives of classification are as follows. 1. The data is presented in a concise form. A raw data as such has no meaning. But once it is classified, it will reflect some meaning. 2. Classification helps in identifying the similarities and diversities in the data. For example, based on the marks obtained in an English test, students can be grouped into those obtaining 76 to 100, those obtaining marks between 51 to 75, those obtaining marks between 26 to 50, and those obtaining marks between 1 to 25. Each of these groups are distinct from each other in terms of marks obtained, but are grouped because of similarity of marks obtained by them. Refer to Table 8.1.
Table 8.1 Marks obtained by students. Marks obtained जो कि फर्स्ट कॉलम है उसमें 76 to 100 मार्क्स 28 स्टूडेंट्स को है. मार्क्स obtained कॉलम 1 रो 2 51 to 75% मार्क्स जो ऑब्टेन किए हैं वो 40 स्टूडेंट्स को ऑब्टेन किए हुए हैं. और थर्ड रो कॉलम 1 में 26 to 50 स्टूडेंट्स हैज़ ऑब्टेन मार्क्स are those who are 12 numbers of students, and 1 to 25 marks are 20 numbers of students. So this is the table that is table 8.1. We will go to the point number 3.
3. Classification also helps in comparisons. The groups can be compared with each other and conclusions can be drawn. Computation of percentage will tell us the percentage of students falling in each of the 4 groups mentioned in the above example. 4. Classification can be carried out for both qualitative as well as quantitative data. Individuals can be classified on the basis of color of their hair or gender, that would be qualitative data. And individuals can also be categorized based on quantitative data, for example, their income, their age, and so on. Statistical methods. 132. One way in which quantitative data can be adequately classified is with the help of frequency distribution, that will be discussed in detail later in this unit. 8.2.2 Tabulation. Tabulation is the process of insertion of classified data into tabular form. A table is a symmetric arrangement of statistical data in rows and columns. Rows.
यहीं पे मैं पॉज करके कुछ बताना चाहता हूँ क्योंकि अभी इस सब्जेक्ट में ज़्यादातर टेबल्स ही रहेंगे और इसलिए मैं आपको रिक्वेस्ट करूँगा कि आप अपने बुक्स को ले लीजिए क्योंकि जो अरेंजमेंट मेरे पास है यहाँ पे स्क्रीन पे उसमें टेबल्स शायद शो नहीं हो पा रहे हैं करेक्टली. सो डेटा करेक्टली नहीं इंटरप्रेट किया जा रहा है. एनीवे बट आपकी किताब में ये सही पे दिया गया है. अभी अगला टेबल जो है 133 पेज पे है टेबल 8.2. आप अपनी किताब ले लीजिएगा. ठीक है.
Rows are horizontal arrangements, whereas columns are vertical arrangements. It may be simple, double, or complex depending upon the type of classification used for various purposes at any given time by an individual. Tables are an important aspect of any research report or thesis. Any table will have some key components that are discussed as follows. 1. Table number. Any table needs to have a table number. In various units, of this course, you will notice that all the tables are numbered. This mainly helps in identification of the table as well as provides a reference. So if you are asked to refer to say table 8.2, you know exactly where to look for it in this unit. Table numbers need to be provided in a systematic manner and in serial order, especially if you have included more than one table in your report or thesis. 2. Title for the table. Besides table number, a table should also have a title that should be specific in nature and should in short reflect what the table is about. Such a title also needs to be clear and self-explanatory and should instantly help the reader gauge what the table is about. 3. Captions and stubs. Any table will then have rows and columns based on its contents. The headings given for columns are termed as captions, whereas stubs are the heading that are given to the rows. These again need to be concise and self-explanatory. The captions and stubs will be decided by the researcher based on the research she is carrying out. 4. Body of the table. Body of the table is the main part of the table that reflects the numerical information that is collected based on the data collection. The numerical data here will be classified based on the captions and stubs. 5. Headnote. Tables also have headnotes which could be written in extreme right below the title, and these provide information about units of measurement. 6. Footnote. These are written below the table and may display crucial information about the information given in the captions and stubs. 7. Source of data. The source of data can then be mentioned below the table.
जिस टेबल के बारे में अभी बोल रहे थे वो यही मतलब टेबल किस प्रकार की होती है इज़ द एग्जाम्पल शोन इन द स्क्रीन नाउ. So any table has a number, any table has a title, any table has captions and stubs. Okay, then the body of the table, okay, head note, ठीक है, और फुट नोट भी है, ठीक है, एंड सोर्स ऑफ डेटा. यानी कि और कुछ बताया गया है कि इनको कहते हैं कॉलम और इनको कहते हैं रोज. ये रोज है और ये कॉलम है. ये तो मतलब समझ गए ना आप, ठीक है. हम अभी अपने रीड आउट पे वापस जाते हैं.
As discussed above, classification and tabulation are significant in organizing the data. Some of the merits of classification and tabulation are as follows. 1. Clarifies the data. The information arranged in the form of table is easily accessible and provides adequate and clear information to the user of the data. 2. Simplification. Classification and tabulation of data reduces the mass, that is, the size of the data, and present the data in simplest possible way. When the data is presented in the tables and classified, all the complexities are removed and the data is made very simple and clear for the user. 3. Facilitates comparisons. It enables quick comparison of the statistical data shown in rows and columns. 4. Information can be easily referred. When an information is tabulated, it is very easy to refer to. 3. Construction of frequency distribution. Earlier in this unit we discussed about classification and tabulation of data. And frequency distribution is a way in which raw data can be classified so as to provide a clear understanding of the data. Frequency distribution is a tabular representation in which the raw data is organized into class intervals. Frequency distribution can be categorized into 3 types. 1. Relative frequency distribution. Such a distribution denotes that the score that is allotted for each class interval is the proportion of total number of cases in a distribution. For example, in a frequency distribution of 100 employees based on years of experience, 35 employees fall in the range, class interval, 10 to 14 years of experience, then the relative frequency distribution will be 35 100ths equals 0.35. Thus, it can be said that 35% of the employees fall in this class interval. 2. Cumulative frequency distribution. Such a distribution for a certain class interval is summation of the frequencies of that class interval and of the class interval below that class interval. This will be discussed in detail in the next section of this unit. 3. Cumulative relative frequency distribution. In such a distribution, the cumulative relative frequency for a particular score is the relative frequency for that score in summation with the relative frequencies of all the scores that lie before this particular score. This will be clear from Table 8.3, that provides examples of the 3 types of frequency distribution. Table 8.3. Examples of relative frequency, cumulative frequency and cumulative relative frequency distributions.
Table 8.3, examples of relative frequency, cumulative frequency and cumulative relative frequency distributions. can see the scores like 34, 23, 22, 21 and 19, and then you can see the frequency 3, 4, 10, 6, 7. Okay, then the relative frequency is reduced from the scores and the frequencies. It's like 10%, 13.33%, 33.33%, and you can see that the results. And in fact, I would like to request you all to go to your textbook, have a look at the table, and find out how these results came into. And if at all any questions you have, you can ask me on the comment section. I'd be happy to help you. We will continue the readout. Okay.
Distribution. There are two main methods to describe class interval. 1. The exclusive method. In this method, the upper limit of a certain class interval is the lower limit of the class interval next to it, thus there is a continuity between the class intervals. The score that equals the upper limit of a class interval is exclusive in the sense that it will fall in the class interval where the score is its lower limit. Thus, in exclusive method the score equal to upper limit is not included in that class interval, but a score equal to its lower limit is included in it. For example, in a distribution with class intervals using exclusive method, a score 20 will fall in class interval 20 to 30 and not in 10 to 20 class interval. 2. The inclusive method. In inclusive method there is no continuity between the class intervals, and this method is especially for discrete scores. In this method, scores equal to both lower and upper limit are included in the class interval. For example, the class intervals will be 1 to 5, 6 to 10, 11 to 15 and so on. Frequency distribution can also be categorized into ungrouped or grouped frequency distribution. Ungrouped frequency distribution. An ungrouped frequency distribution is the one in which all the values are listed in an ascending or a descending order. Based on the frequency of occurrence of each score, a tally mark is placed in front of the respective value and frequency, denoted by F of each score as stated in the next column. The example of ungrouped frequency distribution is given in Table 8.4.
Table 8.4, ungrouped frequency distribution, values, tallies, and function.
Grouped frequency distribution. Sometimes the data is too large and it is not possible to have a frequency distribution in an ungrouped form, as then the researcher will not be able to get a clear picture. In such cases, a grouped frequency distribution can be used. Here the data are organized into classes or class interval, and then a tally mark is placed based on which class interval a given score falls in, and then the frequency is denoted. The example is given in Table 8.5.
Table 8.5, grouped frequency distribution. टेबल तो विजुअल रिप्रेजेंटेशन होता है, मतलब आपको देखना ही पड़ेगा, सुन के काम नहीं चल पाएगा. ओके, आगे बढ़ते हैं.
Grouped and ungrouped frequency distribution must be clear from the above examples. We will now discuss computation of frequency distribution with the help of an example. Suppose, in a class of 40 students, following marks were obtained on a test of 10 marks. The marks obtained by the 40 students are given as follows.
Marks obtained by the student is as follows.
Marks of the students are called as raw data, as they are obtained from the field directly and haven't gone through any statistical analysis. Now the question is, what these numbers or raw data suggest about the target population of students? Which marks are most common? How many students got highest marks? How many students passed this test? With raw data, though, it is not possible to draw any conclusion. Thus, we need to create a frequency distribution on the basis of the raw scores. Frequency can be calculated for each of the obtained score by the students. Frequency is the number of times a particular variable, individual, or observation, obtained marks in our context, occurs in raw data. The distribution of a variable is the pattern of frequencies of the observation. Frequency distributions are portrayed as frequency tables, histograms, or polygons. It is just the arrangement of scores and the frequency of occurrence within a group. A frequency distribution table is one way you can organize data so that it makes more sense to the reader. As discussed earlier, there are two major types of frequency distribution and ungrouped frequency distribution. The computation for both these frequency distributions are discussed as follows. 8.3.1 Computation of ungrouped frequency distribution. To calculate frequency, we are going to use Tallyscore method. This method consists of making a stroke in the proper class for each observation and summing these for each class to obtain the frequency. It is customary for convenience in counting to place each fifth stroke through the preceding four. Quote. Lawal, 2014, page 13. The frequency can be tabulated as follows, based on example of marks obtained by 40 students. Frequency table. Only one student got full marks. Most common marks is 5 followed by 6. Only one student scored 0 on the test. The steps involved in creating an ungrouped frequency distribution are as follows. Step 1. Arrange your raw data in an array ascending or descending order. Step 2. Make a table with 3 columns and name them as variable, that is, marks in the case of the present example, tallies and frequency. Step 3. Enter your variables, marks in case of this example, in the first column from lowest to highest order. Count the tally marks for each variable and write its total in third column, that is, frequency column. 8.3.2 Computation of Grouped Frequency Distribution. One disadvantage of the ungrouped frequency distribution method is that it will be tiresome and difficult to make a table for larger values or observations. 50. Then would it be convenient to make an ungrouped frequency distribution table for such data? Probably no. Then what can we do? We can use another statistical procedure called as grouped frequency distribution method. To understand this method, let us take another example. Suppose you have the scores obtained by students on class test in history. 1 2 7 1 3 1 4 1 2 2 3 2 1 1 4 1 3 2 3 3 0 1 2 1 2 1 2 3 2 1 2 3. Range equals highest score lowest score, R equals HL. Thus, R equals 35 minus 1 equals 34. Step 2. The class interval can be derived by dividing the range by number of categories that we need. Number of categories needed in our example, the range is obtained as 34, and total number of scores, number of students, are 30. Thus, around 6 categories would be sufficient. Thus, I equals 34 sixths equals 5.7, that can be rounded off to 6. While creating categories, ensure that not more than 10 categories are created if there are approximately 50 scores, not more than around 10 to 15 categories are created if the scores are between 50 to 100, and not more than 20 categories are created if the scores are more than 100, Mongol, 2002. Make sure you have a few items in each category. For example, if you have 20 items, choose 5 classes, 4 items per category, not 20 classes, which would give you only 1 item per category. It is sometimes possible that the I obtained is not a whole number. In such a situation, a number nearest to this obtained number can be taken. For example, if I is obtained as 5.8, then 6 can be taken being the nearest number. It is also possible that the class interval or I is finalized before the number of categories are decided. For convenience, the class interval of 10, 5, 2, for example, can be taken. Thus, class interval can be derived in either way as mentioned above. A table can now be created. The following is to be done to create a frequency distribution table. For this, a table with 3 columns is to be created with variable, that is, marks in the case of the present example, tallies and frequency. This is similar to the steps followed in creating an ungrouped frequency distribution. B. Then enter your variables in the first column. C. Go through your raw data and make a mark for each variable next to its value in the second column of your table. D. Count the tally marks for each variable and write its total in third column. 25 to 30, 2. 19 to 24, 11. 13 to 18, 5. 7 to 12, 8. 1 to 6, 3. Total 30. Step 4. Totaling the frequencies. All the frequencies in the third column are totaled, and the number thus achieved needs to be equal to the total number of scores. In case of our example, n equals 30 and the total of frequencies is also 30. Check your progress to 1. Look at the cumulative frequency distribution. Cumulative frequency can be obtained when we successively add all the frequencies from the bottom of the distribution, Mongol, 2002. A cumulative frequency distribution table is a more meticulous table. It looks similar to a frequency distribution table, but it has added column that gives the cumulative frequency. Let us understand the cumulative frequency distribution table with an example. In a walking race conducted by a club, all 10 of the participants had to fill out a form that gave their personal and demographic details. Participants filled in various details, but here we will consider their age for constructing the cumulative frequency distribution table. The ages, in years, of the participants were as follows: 36, 48, 54, 92, 57, 63, 66, 76, 66, 80. Now, answer the following questions based on above raw data. How many participants aged less than 45? How many participants aged more than 44? What is the percentage of participants who are older than 65 years? The answer to these questions can be best given using cumulative frequency distribution method. These are called as cumulative frequencies because they tell how many scores are accumulated up to this point on the table. Aaron and Coos, 2013, page 7. Data organization and graphical representation. 141. Let us present this data in a cumulative frequency distribution table. Step 1. Divide the values into intervals and then count the number of values in each interval. In this case, intervals of 10 are appropriate. Since 36 is the lowest age and 92 is the highest age, start the intervals at 35 to 44 and end the intervals with 85 to 94. Step 2. Create a table similar to the frequency distribution table but with 3 extra columns. Step 3. In the first column or the lower value column, list the lower value of the intervals. For example, in the first row, you would put the number 35. Step 4. The next column is the upper value column. Place the upper value of the intervals. For example, you would put the number 44 in the first row. Step 5. The third column is the frequency column. Record the number of times a value appears between the lower and upper values of the intervals. For example, in the first row, place the number 1. Step 6. The fourth column is the cumulative frequency column. Here, we add the cumulative frequency of the previous row to the frequency of the current row. Since this is the first row, the cumulative frequency is the same as the frequency. However, in the second row, the frequency for the 35 to 44 interval, i.e., 1, is added to the frequency for the 45 to 54 interval, i.e., 2. Thus, the cumulative frequency is 3, meaning we have 3 participants in the 34 to 54 age group. 1 plus 2 equals 3. Steps 7 and 8 can be added to obtain cumulative percentage frequency. Step 7. The next column is the percentage column. In this column, list the percentage of the frequency. To do this, divide the frequency by the total number of values and multiply by 100. In this case, the frequency of the first row is 1 and the total number of values is 10. The percentage would then be 10. 1 divided by 10 times 100 equals 10. Step 8. The final column is cumulative percentage frequency. In this column, multiply the cumulative frequency by 100 and then divide it by the total number of values. Note that the last number in this column should always equal 100.0. In this example, the cumulative frequency is 1 and the total number of values is 10, therefore the cumulative percentage frequency of the first row is 10.0. 1 times 100 divided by 10 equals 10. Statistical methods I. 142. The cumulative frequency distribution table will look like this. Lower value, age in years. Upper value, age in years. Frequency, F. Cumulative frequency. Percentage, cumulative percentage frequency. 859411010100. 7584292090. 6574272070. 5564252050. 4554232030. 3544111010. N equals 10. Based on preceding table, now following information can be obtained. Number of participants aged less than 45 years equals 1. Number of participants aged more than 44 years equals 9. Percentage of participants aged above 65 years equals 50%. Note that cumulative frequency can easily be converted to cumulative percentage frequencies by carrying out multiplication between the cumulative frequency and 100 and dividing by n. N is the total number of frequencies in the distribution. Cumulative percentage frequencies provide information about the percentage of frequencies that lie below a certain score. Class interval, Mongol, 2002, ranks. There are two terms that are used frequently in academic and corporate world: percentile and percentile ranks. Both these statistical terms are used as indicators of performance in comparison to others in a large group. It can be said that these indicators are relative measures of one's performance. There are many tests that report scores in percentile or percentile ranks. You may have heard about Common Aptitude Test, CAT, a common entrance exam conducted for MBA admissions in India. This exam gives result in percentile. For example, a student may obtain 90th percentile in math ability and 84th percentile in verbal ability. In this section of the unit, we will discuss about the terms percentile and percentile rank and also learn how to compute them. Percentile. A percentile can be explained as a point on the score scale below which a given percent of cases lie. Mongol, 2002, page 56. For example, if a student obtained 90th percentile, P90, it means that 90% of the students have scored below him, her, or if the student obtains 84 percentile, P84, then 84% of the students lie below him, her. Percentiles are expressed in terms of percentage of persons in the standardization sample who fall below a given raw score. A percentile will show an individual's relative position in the standardization sample. There is the difference between rank and percentile. In ranks we count from the top and the best person in the group gets rank 1. However, in percentile we count from the bottom and lower the percentile, poorer as an individual's position in the group. The 50th percentile or P50 is like the median. Above 50th percentile denotes above average performance while below P50 denotes below average performance. Percentiles are different from percentage scores. Percentage scores are raw scores which are expressed in terms of percentage of correct items, while percentiles are derived scores. Advantages of percentile scores: 1. It is universally applicable. 2. It can be readily understood and are easy to compute even by untrained persons. Statistical methods I. 144. 3. Is suitable for any type of test. Drawbacks of percentile scores: 1. Percentiles show individuals' relative position in the normative score but not the individual score compared with one another. 2. Percentile score have inequality of the unit and this is a major drawback. Computation of percentile. Percentile can be computed as follows. The formula for computation of percentiles is similar to that of median, Mongol, 2002. P equals L plus Pn 100F, F, Xi where L equals the lower limit of the percentile class or the class where the percentile may lie. P equals number of percentile for which calculation is to be carried out. N equals the total number of frequencies. F equals total of the frequencies that exist before the percentile class. F equals frequency of the percentile class. I equals the size of the class interval. Thus, the formula for first percentile would be P1 equals L plus N 100F, F, Xi, and the formula for 10th percentile would be P10 equals L plus 10N 100F, F, Xi equals L plus N 10F, F, Xi. And the formula for 75th percentile would be P75 equals L plus 75N 100F, F, Xi equals L plus 3N 4F, F, Xi. Let us now compute percentile with the help of an example given in Table 8.7. Table 8.7, Data for computation of percentile. Class interval F. 25295. 20244. 15196. 10144. 594. 047. N equals 30. 30th percentile for the above data, we will compute with the help of the following steps. Step 1. Find the class interval within which the 30th percentile will fall. P30 indicates that 30% of the scores lie below this point. Thus, 30% of n equals 30 by 3100ths equal.
By this time, I would like to tell you that you need to be sitting with the rough notebook, so that you should practice this, because these are the formulas and then datas which if you only hear you would not understand much. You have to take the data in your hand, that means the problems in your hand, and then try to solve it. The formulas are relatively simple. The formulas has different parts which are already mentioned, like PR is percentile rank and R is the rank position, and then you have to insert that same thing into the formula so that you will get the result. Okay, so I would like you to sit with a rough notebook so that you could jot down the problems and solve them while going through this textbook. Okay, so let's continue.
100ths equals 9. Now as we look at the data, the ninth score from below lies in the class interval 5 to 9. Step 2. L, that is, the lower limit of the percentile class or the class where the percentile may fall is identified. In the case of this example, it will be 4.5, that is the lower limit of class interval 5 to 9. Step 3. F, that is, total of the frequencies that exist before the percentile class is 7. In case of this example in F, that is, frequency of the percentile class is 4. Step 4. Formula. P30 equals L plus 30N 100F, F, Xi equals 4.5 plus 30 by 3107, 4, X5. Equals 4.5 plus 9 to 7, 4, X5 equals 4.5 plus 2 quarters X5. Equals 4.5 plus 2.5 equals 7. Thus, the obtained P30 is 7, that falls in the class interval 5 to 9. Percentile ranks. In statistics, percentile rank refers to the percentage of scores that are identical to or less than a given score. Percentile rank can be explained as the number representing the percentage of the total number of cases lying below the given score. Mongol, 2002, page 60. Percentile ranks, like percentages, fall on a continuum from 0 to 100. For example, a percentile rank of 50 indicates that 50% of the scores in a distribution of scores fall at or below the score at the 50th percentile. Percentile ranks are beneficial when you want to quickly understand how a specific score compares to the other scores in a distribution. For instance, knowing someone scored 300 points in an exam does not tell you much. You do not know how many points were possible, and even if you did, you would not know how that person scored compared to the rest of his/her classmates. If, however, you were told that she scored at the 95th percentile rank, then you would know that she did as well or better than 95% of his/her class. Computation of percentile rank. Percentile rank can be computed for an ungrouped data as well as grouped data. These computations have been discussed as follows with the help of examples. Computation of percentile rank for ungrouped data. The formula for computation of percentile rank for ungrouped data is PR equals 100 to 100 R50 N, where PR equals percentile rank. Statistical methods I. 146. R equals the rank position of the person for whom the percentile rank is to be computed. N equals total number of persons in the group. We will now compute percentile rank with the help of the following data. The marks obtained by 10 students in a psychology test are given as follows: 34, 45, 23, 67, 43, 78, 87, 56, 88, 46. We will now find percentile rank for the mark 67. Step 1. The marks are to arranged in descending order as follows. Marks rank order: 88 1, 87 2, 78 3, 67 4, 56 5, 46 6, 45 7, 43 8, 34 9, 23 10. Step 2. Rank for the marks are identified. As can be seen above, the rank for mark 67 is 4 and N is 10. Step 3. Let us now substitute the values in the formula. PR equals 100 100 R50 N equals 100 100 x 450 tenths equals 100 400 minus 50 tenths equals 100 350 tenths equals 100 minus 35 equals 65. Thus, the percentile rank obtained for rank 67 is 65. Computation of percentile rank for group data. There are two methods for computing percentile rank for group data. One is where such formula is not required and the other where formula is required. Data organization and graphical representation. 147. We will now compute percentile rank with the help of the following data. Marks F. 90991. 80893. 70792. 606910. 50599. 40493. 30396. 20297. 10198. 091. N equals 50. We will compute percentile for marks 35. Method 1. Without formula, the steps in this computation are discussed as follows. Step 1. We know that the marks 35 fall in the class interval 30 to 39. If we add the frequencies that are below the upper limit of class interval 20 to 29, that is 29. 5. There are 7 plus 8 plus 1 equals 16 cases. Step 2. We need to find out the number of cases that lie below 35. Thus, 35 to 29.5 equals 5.5. Step 3. The frequency distribution for class intervals 30 to 39 is 6. Thus, these 10 marks, 30 to 39, are shared by 6 individuals. The interval shared by each of the 6 individuals is 5.5. 6 tenths by 5.5 equals 3.3. Step 4. Thus, up to marks 35, there are 16 plus 3.3 equals 19. 3 or 19 cases. Step 5. To present these cases on a scale of 100. We multiply these cases with 100 n equals 50. 19.3 by 150ths equals 1930 50ths equals 38. 6. Thus, the percentile rank is 38.6 or 39 for marks 35. Method 2. With formula, the formula for computation of percentile rank for group data is PR equals 100 N F plus XL I XF. Statistical methods I. 148. Where PR equals percentile rank F equals the cumulative frequency that lies below the class interval that consists of XX equals the marks for which the percentile rank is to be computed. L equals the lower limit of the class interval that consists of XI equals size of the class interval. F equals frequency of the class interval that consists of XN equals total number of cases in the distribution. We will take the same example discussed above and compute the percentile rank for marks 35 with the help of the formula. Step 1. The cumulative frequency below the class interval, 30 to 39, that consists of x, 35, is 16, 7 plus 8 plus 1. Thus f is 16. Step 2. L, that is, the lower limit of the class interval that consists of x, is 29.5, I equals 10 and f equals 6. Step 3. Let us now substitute the values in the formula. PR equals 100 n, f plus, xl, I, xf, equals 150 s, 16 plus, 35 to 29.5, 10 x6. Equals 2, 16 plus 5.5, 10 times 6 equals 2, 16 plus 3.3, equals 2 by 19.3. Equals 38.6. Thus, the percentile rank is 38.6 or 39 for marks 35. Percentile and percentile rank can be termed as important in statistics as they not only provide information about the comparative position of an individual in a particular group based on certain characteristics, but they also help in comparing individuals in two or more groups or under two or more circumstances or conditions. For example, if a learner from one college obtained 55 marks in psychology and another learner from another college obtained 65 marks, these cannot be compared. But if these marks are converted into percentile rank and then it is stated that both have 60th percentile rank, then a comparison is possible. Percentiles also play an important role in standardization of psychological tests where the raw data can be converted to percentiles and interpreted. When an organized data is graphically represented, it not only looks attractive but it is easier to understand. A large amount of data can be presented in a very concise and attractive manner. Graphs are effective and economical as well. They are also easy to interpret and adequately reflect any comparison between two sets of data. There are various types of graphs like bar graph, histogram, frequency polygon, etc. that can be effectively used to graphically represent data. However, one must know when to use which graphs. Let us now discuss various types of graphs. 8.6.1 Bar graph or bar diagram. A bar graph is also called as bar diagram. It is the most frequently used graph in statistics. A bar graph is a type of graph which contains rectangles or rectangular bars. The lengths of these bars should be proportional to the numerical values represented by them. In bar graph, the bars may be plotted either horizontally or vertically depending on the interest of the plotter. Statistical methods I. 150. Bar graph or diagram can be easily drawn for raw scores, frequencies, percentages and mean. Mongol, 2002. The following needs to be taken care of while drawing bar graphs. Mongol, 2002. 1. Rules need to be followed with regard to the length of the bars, though no rules are applicable to the width. All the bars need to be of equal width. The lengths or heights of the bars in the bar graph need to in proportion with the amount of variables. 2. The space between two bars could be around half of the width of a bar and the space between any two bars should be same. The steps followed while drawing a vertical bar graph are as follows. Step 1. On a graph paper, draw the vertical, y-axis, and horizontal, x-axis lines. These lines should be perpendicular to each other and need to intersect at 0. Step 2. Provide adequate labels to the y-axis and x-axis. Step 3. A scale needs to be selected for the length of the bars that is usually written on the extreme right at the top of the bar graph. Step 4. On x-axis, we need to select a width for the bars as well as the gap between the bars that needs to be uniform. Step 5. Based on your data, you may then draw the graph. An example of bar graph or diagram is given in Figure 8.1, which is based on the Table 8.1 that reflects the marks obtained by students in a class test in psychology of 100 marks. There are 20 students who scored marks between 1 to 25, 12 who secured marks between 26 and 50, 40 students who secured marks between 51 and 75, and 28 students secured between 76 to 100 marks. The bar graphs based on Table 8.1 will look as follows. Fig. 8.1, bar graph. 20. 12. 40. 28. 0, 10. 20, 30. 40, 50. 1 to 25, 26 to 50, 51 to 75, 76 to 100. BRO. FS2. To NT. S. Marks obtained. Data organization and graphical representation. 151. 8.6.2 Histogram. A histogram is a bar diagram that can be drawn based on frequency distribution. The following steps are to be taken while drawing a histogram. Step 1. Histogram is based on frequency distribution and a grouped frequency. Distribution has class intervals, therefore, before drawing a histogram, two more class intervals are added, one below and one above. As can be seen in Table 8.8. The frequency distribution originally had 5 class interval, but 2 more, one below and one above, have been added. Step 2. Further for histogram, the class intervals are changed as can be seen in Figure 8.2. Where class interval 10 to 19 has changed to 9.5 to 19.5 and so on. Step 3. On x-axis, the actual lower limits of all the class intervals are then plotted. And frequencies are plotted on the y-axis. Step 4. A single rectangle will then represent each frequency. Ensure that the height of the graph is around 75% of its width. Table 8.8. Data for histogram. Class intervals 10. Class intervals taken for histogram. Frequencies 70 to 79 69.5 to 79.50. 60 to 69 59.5 to 69.55. 50 to 59 49.5 to 59.54. 40 to 49 39.5 to 49.513. 30 to 39 29.5 to 39.512. 20 to 29 19.5 to 29.510. 10 to 19 9.5 to 19.50. Fig. 8.2. Histogram. 0. 3.5. Frequency polygon can either be constructed directly or it can also be constructed by drawing a straight line through the midpoints of the upper base of the histogram, Mongol, 2002, that is shown in figure 8.4. Steps followed while drawing a frequency polygon are as follows. Step 1. As we know that the frequency polygon is based on frequency distribution. In case of frequency polygon as well, before drawing a frequency polygon, two more class interval are added, one below and one above. As can be in table 2.9. Step 2. For all the class intervals, midpoints are computed. Step 3. Like every graph, frequency polygon also has x-axis and y-axis. On x-axis, the midpoints are to be plotted and the frequencies will be represented on the y-axis. Step 4. The corresponding frequencies of the class intervals are then plotted based on the midpoints given on x-axis. Step 5. These points are then joined to form a line. Ensure that the height of the graph is around 75% of its width. Once plotted, the frequency polygon will look as given in figure 8.3. Table 8.9. Data for frequency polygon class intervals, 10, midpoints of class. Intervals frequencies. 70 to 79 74.50 60 to 69 64.55 50 to 59 54.54 40 to 49 44. Cumulative frequency percentage curve or Ogive. Cumulative frequency percentage can be plotted in form of a graph, and this graph is called as cumulative frequency percentage curve or Ogive. Such a graph is a line graph. On y-axis the cumulative frequency percentages are plotted, and on x-axis, the upper limit of the class intervals are plotted. This graph lacks a negative slope, and when a certain class interval has zero frequency, then the line or curve will remain horizontal. As was discussed under section on cumulative frequency distribution, cumulative frequency percentage is computed by multiplying the cumulative frequency by 100 n, where n stands for total number of frequencies. The steps to draw a cumulative frequency percentage curve or Ogive are as follows. Step 1. The frequency distribution table should be ready with computation of cumulative frequency percentages. Step 2. Plot the cumulative frequency percentage on y-axis and the upper limits of class interval on x-axis. Step 3. Plot the points representing the cumulative frequency percentage for each class interval. Step 4. Join the points with the help of a line. Auto-reorganization and graphical. E-presentation. Statistical methods I. 154. Table. Class intervals 10. 60 to 69. 50 to 59. 40 to 49. 30 to 39. 20 to 29. 10 to 19. 8.6.5. Circle a pie chart which contains the numerical data. This is considered steps in construction. Step 1. Surface area. Step 2. The component. 8.10. Data for cumulative frequency and frequency percentage. Upper limit of class intervals. Frequencies. Cumulative frequencies. 69.5 10 44. 59.5 12 34. 49.5 13 22. 39.5 49. 29.555. 19.500. Fig. 8.5. Cumulative frequency percentage curve. Graph or pie chart is also known as a circle graph. A pie chart. A circle which is divided into sectors, proportion of the data. Each portion of. Circle graph is called as pie chart because pi, when the circumference of a circle is determined. Of a pie chart, the data represented here is presented through. But the circle covers 2 pi or 360. Total frequency is considered equal to 360. Part is computed. This is done by using the cumulative. Cumulative frequency percentage. 100. 77.27. 50. 20.45. 11.36. 0. Or Ogive. is defined as a graph these sectors illustrate. The circle represents the pi is a quantity that Mongol 2002 360 because the and then angle for each formula. Data organization and graphical representation 155. Frequency of the component total frequency x 360. If the components are presented in percentages, then the formula used is percentage value of a particular component 100 x 360. Step 3. The sections are then drawn after the angles are determined. Table 8.11. To sum up, in this unit we initially discussed about classification and tabulation of qualitative and quantitative data. In descriptive statistics, classification and tabulation of data, whether qualitative or quantitative, are two important functions that help researchers in organizing the data in a better manner and then to subject it to further statistical analysis. Data classification is the method of organizing data into groups for its most effective and efficient use. Well-planned data classification system makes vital data easy to find and retrieve whenever required. Tabulation, on the other hand, is the process of insertion of classified data into tabular form. A table is a symmetric arrangement of statistical data in rows and columns. We also discussed about the key components of tabulation. The significance of classification and tabulation was also highlighted. Further, in this unit, we discussed about frequency distribution. Frequency distribution is arranged in a tabular form in which the raw data is organized into class intervals. Frequency distribution can be categorized as relative frequency distribution, cumulative frequency distribution, and cumulative relative frequency distribution, which were discussed in the unit with the help of examples. Besides the two main methods, namely, the exclusive and inclusive methods, of describing class interval and frequency distribution were also discussed. The unit then focused on computing frequency distribution for both ungrouped and grouped data. The steps involved in creating a cumulative frequency distribution were also highlighted. Cumulative frequency percentage was also explained in the unit. Further, the unit focused on the concepts and computation of percentile and percentile rank with the help of examples. A percentile can be explained as a point on the score scale below which a given percent of cases lie, and percentile rank refers to the percentage of scores that are identical to or less than a given score. The last section of the unit explained the graphical representation of data. A graph is the representation of data that uses graphical symbols such as lines, bars, pie diagrams, dots, etc. When an organized data is graphically represented, it not only looks attractive but it is easier to understand. A large amount of data can be presented in a very concise and attractive manner. Graphs are effective and economical as well. In the present unit, bar graph, histogram, frequency polygon, cumulative frequency percentage curve or Ogive and chart were discussed in detail with the help of examples and figures.
इसी के साथ हमारा यूनिट 8 ख़त्म हो गया है और हम आगे बढ़ेंगे यूनिट 9 के लिए अगले वीडियो में. होपफुली जो स्पीड ऑफ रीडिंग जो है वो नॉर्मल है और आपको सब अंडरस्टैंड हुआ होगा, ऐसे मैं मतलब मान के चल रहा हूँ. अभी एज आई टोल्ड यू दिस chapter is kind of having maths and also it requires a constant concentration. You cannot just listen, but you will have to take a notebook as well as sit with that and write down the formulas and the values and play with the numbers. So yes, this has this arrangement of data into all this polygon or whatever, like histogram or this charts, graphical representation. This is a little difficult just for listening, but if you are sitting with a notebook, it will be quite easier for you. Okay, thank you for listening. Give a thumbs up and please subscribe to the channel.